Now in this lecture we will talk about structure of ethers, right? So now we have structure of ethers. In the previous lecture we said that ethers can be considered, or ethers are derivatives of water in which hydrogen atoms are replaced by alkyl groups, right? Like this. This is how we draw water. We have two lone pair of electrons, right? Now if I replace two hydrogen atoms, right, by your alkyl groups, what I will get is a ether, right? So ethers have similar structure as that of your water, right? So ethers have similar structure to that of water, right? Both have similar structure, but with some differences, right, of bond angle and other things. We'll see why the bond angle differs in ethers as compared to in alcohols. We know that in alcohols the bond angle is 105, to be exact 104.5, right? But in ethers the bond angle would be 110, right? We'll see, it might increase in ethers, we will see that in a moment, right? So when we talk about structure, we talk about hybridization, we talk about bond angle, we talk about dipole moment, right? We talk about bond length, all these things, right? So we'll see all that. Now we'll be looking into the hybridization of oxygen atom. We know that oxygen atom, it's Z is equals to 8, right? So its electronic configuration is 1s2, 2s2, 2px2, 2py1 and 2pz1, right? Oxygen atom is sp3 hybridized, right? sp3 hybridized means 1s and 3p would hybridize, right? These would hybridize, right? This will undergo sp3 hybridization, right? When it will undergo sp3 hybridization, it will form 4 equivalent set of sp3 hybrid orbitals, right? So what it will give is 4 sp3 hybrid orbitals, right? 4 sp3 hybrid orbitals. 2 of them will contain lone pairs of electrons. These 2 lone pairs of electrons would be in 2 of the sp3 hybrid orbitals, right? And 2 these unpaired electrons, 2py1, 2pz1, these 2 orbitals have an unpaired electron which would be in other 2 hybrid orbitals, right? So it would be somewhat like this, right? So these 2 orbitals contains your lone pair of electrons. Now if you look at this, you have 2 R groups, right? Now these two orbitals that contain single electron, right, will overlap with sp3 hybrid orbitals of these alkyl groups. We know that in alkyl groups your carbon is sp3 hybridized, right? So here the sp3 hybrid orbitals of alkyl groups will overlap with sp3 hybrid orbitals of oxygen atom, right, like this. Right, this is carbon, right, and these are from your alkyl groups, these 2 alkyl groups, right, and this is your sp3 of alkyl group and sp3 of oxygen, same as this, right, to form carbon oxygen sigma bond, right, 2 carbon oxygen sigma bond. This is how the structure looks like, right? So you have 2 lone pair of electrons, right? These two are two lone pair of electrons, and these two are two bond pair of electrons, which is formed by overlapping of sp3 hybrid orbital of oxygen atom with the sp3 hybrid orbital of your alkyl groups. Right? I hope this is clear. And these two will form two carbon oxygen sigma bond. Right? And look at, just know how this hybridization is taking place. Right now, since, let's look at the bond angle now. We are done with hybridization. Let's look at the bond angle. Bond angle in ether is less than, sorry, it's more than, bond angle is more than in water. Right? You can see here it is 110, in water it is 105. This is due to the repulsion between these bigger alkyl groups. Right? We know that hydrogen are small atoms. Right? They have less steric strain, less steric repulsion. But these are bigger groups. Right? These are bigger alkyl groups. So they have more steric repulsion. So when they repel, they will move apart. Right? So when they move apart, this angle between ROR, this angle ROR will increase. Right? Due to steric strain or steric repulsion between bigger alkyl groups. Bigger alkyl groups. Right? As compared to small hydrogen atoms in water. Right? You have bigger alkyl groups, so they will have more steric repulsion, due to which the bond angle increases to 110, right, as compared to 105 in water, because in water you have smaller hydrogen atoms, so they have less steric repulsion. Now, if I take, and show you another ether, right, this. This one. The angle between this is higher. It's around 132. Right? It's around 132 degree, right? Which is even more than your normal ether. Right? This is your the name is tertiary butyl ether, the name of this compound, right? And you can see there are 3 alkyl groups here, 3 alkyl groups here, methyl groups, right? 3 methyl group here, 3 methyl group here. So it's very big structure. So you have more steric repulsion, and it will increase the angle to 132 degree. Here the angle between the bond angle of your ether is 132 degree because of maximum steric repulsion or steric strain, right, due to these bigger alkyl groups, right? So the angle is increasing because of bigger size of the alkyl groups, because bigger size of the alkyl groups means more steric repulsion, right? I hope till this point it is clear, right? So since the structure is bent like that of water, right, or little V-shaped or bent like that of water, so it has a net dipole moment. It is not a linear molecule, right? So it will have a net dipole moment. So ethers have net dipole moment, right? And the dipole moment of ether is around, if we talk about dimethyl ether, it's 1.3 dep, right, for dimethyl ether, and for diethyl ether it is 1.18, right? So I hope this is clear. So in this lecture we have learnt about the structure of ethers, right? Just understand the hybridization of central oxygen atom. It has two lone pair of electrons which are in two sp3 hybrid orbitals. The other singly occupied sp3 hybrid orbitals are used to make sigma bonds with the sp3 hybrid orbitals of these two alkyl groups. Right? Now, if we talk about the bond angle is more in ethers because of the bigger alkyl groups, because they have more steric repulsion, right? And it has a net dipole moment, right? Because it has a bent or V-shaped structure like that of water, so it has a dipole moment. For dimethyl ether it is 1.3 and for diethyl ether it is 1.8 depth, right? I hope this is clear. And if we talk about bond length, right, the bond length is around, it is less than CC bond, right? The bond length CO bond is less than that of your CC bond, right? If we talk about CC bond in ethane, it is 154 pm. If we talk about CO bond in ethers, it is around 142 pm, right? So bond length is less in case of ethers, right? I hope this is clear. Thanks.